let's talk about parallel and perpendicular lines. Let's talk about parallel and perpendicular lines. Okay, we're going to look at parallel and perpendicular lines. Parallel and perpendicular lines. All right, so parallel and perpendicular lines. So we are going to talk about parallel and perpendicular lines. So when we talk about parallel lines, these are simply lines that don't usually meet. So these are parallel lines, and when two lines are perpendicular, they end up forming a 90 degrees somewhere there. So these are perpendicular lines. These are parallel lines. Now, what about parallel and perpendicular lines? When two lines are parallel, their gradient is the same. So when two lines are parallel, they have the same gradient. Okay. So when two lines are parallel, they have the same gradient. What does that mean? So this simply means that if the gradient of the other equation is m1 and the other one is m2, so the two lines m1 and m2 are going to be equal. So the two gradients are going to be equal. So the gradient of the other one and the gradient of the other one are going to be the same. On the other hand, when two lines are perpendicular to each other, it simply means that the product of their gradients is equal to -1. So when two lines are perpendicular, the product of their gradient is equal to -1. Allow me to give an example again on this one. Let's look at several examples. For instance, we want to find the equation of a straight line. Let's say that passes through the point 4, 6. We want to find the equation of the straight line that passes through the point 4, 6. Let's say this line is parallel and perpendicular to the line y is equals to 3x minus 8. Y is equals to 3x minus 8. So how do you find the line that is parallel and perpendicular to this line and it passes through the point 4, 6? What do we do in order to find this line? So the first thing that we are supposed to do, if we are looking for parallel lines, if we are looking for a line that is parallel, so I'll say parallel here, we are supposed to find the gradient. So the equation is y is equals to 3x minus 8. Remember, the general equation is y is equals to mx plus c. The general equation is y is equals to mx plus c. This simply means that the gradient here is equals to 3. Okay, so the gradient that is parallel to this line that we are looking for is equals to 3. And like I stated earlier to say, when two lines are parallel, then their gradient is the same. So this simply means that m1 is equals to m2. So if the gradient of m1 is 3, it means the gradient of the other one is also what? 3. So the gradient of this parallel line is equals to 3. So we know the gradient of this parallel line is equal to 3. So how do we proceed now? This is what we do. So this is what we do. So we fix it in the equation. We say y is equals to mx plus c. So y is equals to 3x plus c. Then we ask ourselves, at which point is this line passing? So this line is passing at the point 4, 6. So since it's passing through the point 4, 6, we are going to replace 4, 6 in the equation that we have. So the equation that we have is this one. Where there's y, we are going to put 6y because this represents y and this represents x. So where there's y here, we are going to put 6, and where there is x, we are going to put the value of 4 plus c. So 6 is equals to 3 times 4 is 12 plus c. C therefore is equals to 6 minus 12. So 6 minus 12 gives us -6. Okay, we get -6. So we can conclude therefore that the line is y is equals to 3x where the c we press -6, 3x minus 6. So this becomes the line that is parallel. Okay, this becomes the line that is parallel. That's how you solve for parallel lines. That's how you solve for parallel lines. So now let's look at the line that is perpendicular to this line. Let's talk about the line that is perpendicular. Let's talk about the line that is perpendicular. So how do you find the line that is perpendicular to this one? So in order for us to find the line that is perpendicular, we must remember that when two lines